Today we'll solve exercise number 2.5 differentiation. Question number 10 part 6 is cot inverse of 2x divided by 1 minus x square. So first step is let y is equal to cot inverse of 2x divided by 1 minus x square. So as you know that derivative of cot inverse of x d by dx, derivative of cot inverse of x is equal to minus 1 by 1 plus x square, minus 1 by 1 plus x square. Now let y is this term, so here variable is x, so we'll differentiate with respect to x. What we get? Differentiate y d by dx cot inverse of 2x by 1 minus x square. We can see that derivative of cot inverse is equal to minus 1 by 1 plus x square. So dy by dx is equal to minus 1 by 1 plus x square, and this whole term we consider as x. So x square. This is not simple as, so again we will differentiate 1 minus x square, this term x. Now further we simplify this 1 plus, we'll separate the whole square in the form of individually square in the numerator and 2x whole square and 1 minus x whole square, 1 minus x square whole square. Now this is derivative of quotient, so derivative of two quotient variable is equal to v, derivative of u minus u, derivative of v whole divided by v square. So we apply here this. We consider this term as u and this term as v. So this term as u and this term as v. So v is 1 minus x square, derivative of u is 2x, minus u is 2x, derivative of v is 1 minus x square whole divided by v square. V is 1 minus x square whole square. Now further we simplify this minus 1 by taking LCM. 1 minus x whole square is LCM. 1 minus x whole square is divided by 1. What we get? 1 minus x square whole square, and the answer we getting is multiplied by 1. 1 minus x square whole square plus 1 minus x square whole square is divided by 1 minus x square whole square. What we get? 1 is multiplied by 2x square, 2x whole square. Now 1 minus x square as it is, derivative of 2x, 2 is constant, derivative of x with respect to x is 1, 2 into 1 becomes 1 minus 2x, derivative of 1 is constant, derivative of 1 is 0, minus x square, derivative of minus x square minus, here we apply power rule according to power rule, and n is 2, x, 2 minus 1 becomes 1, so minus 2x, 1 minus x square whole square. Now we can see that 1 minus square whole square, this term and this term cancel, minus 1 by 1 minus x square whole square, 1 minus x square, 1 minus x square, 1 minus x square multiplied by 2 times, 1 1s are 1, minus 1 plus 1 minus x square, minus plus minus x 1s are x square 1s are x square, minus plus minus x 1 x square 1s are x square, minus minus plus x square becomes x4, 1 minus 2x square plus x4. So 1 minus 2x square plus x4 plus 2 2s are 4 and x square, and 2 is common, and 1 minus x square, 2 is common, 1 2 is common, minus as it is, minus minus become plus, 2x square. So further we simplify this, minus 2 into 1 2 into 2x square minus x square, 2x square minus 1 plus x square, and divided by 1 plus 4x square minus plus 4x square minus 3x square become plus 2x square plus x4. Now this is equal to, now minus 2 1 plus x square, and this is minus if we add 1 square plus 2 a square into b plus b square. So this is a minus 2 1 plus x square. This is a square root of square of 1 plus x square whole square. Now which is equal to dy by dx minus 2 into 1 plus x square divided by 1 plus x square whole square. This 2 and this one cancel, what is left, minus 2 divided by 1 plus x square. So derivative of cot inverse of 2x divided by 1 minus x square is equal to minus 2 by 1 plus x square, which is a required solution.